Good day, viewers, and you are welcome to this class. In today's video, we are going to be finding the derivative of this sine x from the limit definitions. Because if we find the derivative of sine x, ordinarily we have cos x. But how can we show this by limit definition? By considering the definition of a limit, which is f prime of x equals limit at h approaches 0 f of x plus h minus f of x divided by h, and all this in the parentheses, that is all workings under the limit. And is the standard definition we use to solve any problem like this or any functions as far as we're asked to use the limit definition to get its derivatives. So suppose I change this x to x plus h, definitely we have sine x plus h minus sine x divided by h. And the next thing we are going to do here is we apply some trigonometry identity, I mean the double angle identity, from sine of x plus h. That one is going to give us limit at h approaches 0. Sine x plus h gives sine x cos h plus cos x sine h minus sine x divided by h. We know that the whole of sine x plus h gives sine x cos h plus cos x sine h. And the next thing we are going to do is we try to combine the one having negative, which is sine x, with the first one, which is also having sine x, so that we can factor it out. By doing that, we have sine x out, and in the parentheses we have cos h minus 1. Then suppose I separate them with this h, which is by divisions, and also we have this as cos s sine h divided by h. Then by the property of limit, and where this follows additions of a limit, we are going to separate each of these terms in the parentheses with the limit, and here we are going to have the limit at h approaches 0, and for the first one, which is sine x open bracket cos h minus 1 divided by h, and also plus limit at h approaches 0 of cos x sine h divided by h, and s out or out for the second one. And looking at this, we see that h approaches 0, which means that anything like x there become constant, and the limit of any constant is also that constant. So we are going to factor out sine h, and we are left with limit at h approaches 0 of cos h minus 1 divided by h, and we put this thing in the parentheses as sine x is already a constant, which we factor it out. Again, here we have cos x as a constant, then we put limit at h approaches 0 in this, then we have sine h divided by h. But here we have two different identity. Let me call it limit identity, because anytime we limit h tends to 0 of cos h minus 1 divided by h, the whole of it becomes 0, and there is a proof for that, which will be coming out in my next video. For this as well, we have sine h divided by h, which also equals 1. So by doing that, we have this as sine x bracket of 0 plus, and this is also cos x bracket of 1. Therefore, when we multiply sine x with 0, we are going to get 0, and we later conclude that the f prime of x according to the definition of the limit, gives cos x, and this cos x is the derivative of sine x. And as usual, we are done. And thanks for watching. Please don't forget to subscribe to this channel for more exciting math content like this and more. See you in the next class. Bye bye.